Hello grade 12s, we are carrying on with our meiosis revision. So we're moving on from the last video where we were with the questions. Again, please make sure that you go through these questions before, make sure you've done them, make sure you have an understanding before you come to get the answers. So we're carrying straight on into it. Question 4. The diagram below shows a cell in a stage of meiosis. Okay, there's your picture, there's your cell. What should you be looking for? What kind of things are we wanting to look for structures? Before we get to questions, right. Provide labels for A to D. So I'm going to choose labeling here. So, what is A? A little bit of a hop back to when we did mitosis. A is a spindle fiber. Those things that actually attach, we do need to know about them. Don't forget about them. What is B? The little circle that holds these things together. That is the centromere. Then C, well, again, so this is slightly interpretive of what you could have had. You can either say that it is a chromosome, or I would have accepted if you said chromatid, because that just can be a little bit ambiguous in that label from there. And then what is D? Similar to the previous question we had, it's got a bracket around these two chromosomes here, so therefore they are homologous, spelling, chromosomes. Okay, nice and easy labeling. Right, identify the phase of meiosis shown above. Justify your answer. Okay, so we're really getting into this concept of identifying phases. So, what do we notice? What is happening in this cell? Okay, so I've got my chromosomes. What do we feel is happening? Have they separated? No. Is it prophase, where we're having the crossing over? No, crossing over has already occurred in these ones. Essentially what they're doing, they are lining up in the middle. They are lined up in the middle. They haven't separated. So it is definitely metaphase. But is it metaphase 1 or metaphase 2? Go back to the table. Look at the difference between metaphase 1 and metaphase 2. What do we notice in this particular image? They are lined up in 2 rows. They are lined up in their homologous pairs. So what does that mean? It must be metaphase 1. So that is really part of the justification of our answer. Chromosomes lined up in homologous pairs on the or in the middle of the cell. And if you want to show your understanding, not lined up in single file. Maybe you just add a little extra in terms of that. Okay. That is that second one. That is that one. Right, next question. How many chromosomes will be present in the haploid cells produced from the cell in the picture given above? In the picture given above. Not of a normal human cell. In this picture. Make sure you read the question to understand what is being asked. So if you said 23, you're wrong, because that's not what the picture is showing. So, let's count. How many chromosomes are present in this cell? Remember, we count by the number of centromeres present. So it's 1, 2, 3, 4. So 4 cells are in this phase. So therefore, that would represent the diploid number, because we're still in metaphase 1. We haven't had the reduction division yet. So what then is going to be the haploid number? It is going to be 2 chromosomes. Why? Again, explain your answer. The diploid number is 4. Therefore, haploid is half, you could say, which equals 2. Therefore, you're showing your understanding. The diploid number is 4. Haploid, therefore, is half, which is 2. Okay, hope you didn't get tripped up on that. I hope you didn't say 23 chromosomes. Don't assume that it's always a human cell, because you can get questions where it is potentially not a human cell. That can potentially happen. So, just be aware of that. Right. Micrographs. Place the following micrographs of meiosis in the correct order. Wow, okay, now we get to some really nice applied stuff here. So, you're having to do 2 things at once. A, you are having to identify the phases that are being shown in these images, and then B, to put them in the correct order. So, first of all, let's try and identify which cell or what phase is happening in each cell. So you've got A, B, C, and D. Now, when you have micrographs, the easiest way to tell, well, there's two things you need to be able to tell. Which phase? Are you in phase 1 or are you in phase 2? And then you can kind of look at where you are in terms of phases. The first thing and the easiest thing that you should look for is the number of cells present or the number of cells it's going to, because that really does help dictate to you what is happening in each of these cells. So for example, in picture A, how many cells are there? How many is it going to? Well, there is 4 cells. So when is the only time that you're going to see 4 cells? Well, it's either going to be in telophase 2 or in anaphase 2, because anaphase is when it starts moving towards the 4 one. So that already gives us an idea of what's happening here. What is picture B? Well, we can see that there's 4 sets of chromosomes. Right, so I've got 4 cells here and I've got 4 cells here, so they can't be the same phase, so clearly they must be different. Well, if you notice in this picture, you can see almost pretty much the nuclei are starting to reform. It looks like a normal cell, whereas in this picture, you can still see the chromosome structure, you can see them being pulled. So clearly, in this cell, we are right at the end, and in this cell, we are going from 2 cells to 4 cells, and the splitting is occurring. So clearly, A, I'm just writing down what the phases are, I'm not doing the order just yet. Clearly, A is telophase 2, and B is anaphase 2. Okay, that was the first easiest thing for us to do. Let's look at C and D. Right, in D, how many cells are we going to? Well, it's 1 cell. There's only 1 cell that's there. So clearly D is in the first phase of meiosis. Let's look at C. What is it? How many cells or how many is it going to? It's 1 cell going to 2. We can see these chromosomes are moving towards the 2 sides. But in this cell, we had cells moving towards from 2 to 4. In this cell, we are having cells moving from 1 to 2. So, and they're not lined up in the middle, they have separated, they haven't formed the nuclei yet. So clearly, C is anaphase 1. Which leaves us with D. What is D? So D, it's 1 cell. So what have I got left? I've either got prophase 1 or metaphase 1. Because if it was telophase, I would see 2 cells. Or technically it could be interphase as well. But, so it's one of those 3. Interphase, prophase 1, or metaphase 1. Let's look. They are all lined up down the middle. Again, it's not exactly nice and neat. This is a micrograph, looking there. But this pretty much represents lining up in the middle. Therefore, this is metaphase 1. So therefore, what is the correct order of this? Let me just give myself some space here. What, therefore, is the correct order? So the correct order then is D, C, B, A. So it just pretty much went in reverse. D, C, B, A. Because you know it's the 2 first phases. Metaphase comes before anaphase, and anaphase comes before telophase. Okay, do yourself a favor. Go and Google for yourself micrographs of meiosis. Get used to seeing these kind of pictures. It really is a nice way for us to test you to see that you have an understanding of what each of these phases are. Really make sure you get used to doing those types of questions. Okay, moving on. I'm going to try and get everything into one video here, so just bear with me. Right, the photographs below are taken of a lily flower and some cells taken from a certain area. So we're talking about plants now. Right, plant, and here's the cells. Question 1. Name one structure of the flower visible in the picture where you would find these cells. Okay, visible in the picture. Something I must be able to see. So what labels have I got? Sepal, style, petal, position of the ovary, but you can't really see it, filament, and anther. We know that meiosis occurs in the anther. So that is definitely visible. So this answer is anther. Now look at question 2. So now it says, Name one structure of the flower not visible in the picture where you would find these cells. Remember the question asked? Or remember we said before, where will meiosis occur in a plant? We've already said anther. What is the only other place that we can potentially find it? In the ovule, not the ovary, because even though the ovary is not sort of present on here, the ovary does not produce the gametes. The ovule creates the gametes. Okay, identify the stage of meiosis shown by the cells. Justify your answer. Okay, well, this is a fairly easy one. How many cells are there? 1, 2, 3, 4. So if there's 4 and it looks like there's nuclei, the nuclei have pretty much formed, it has to be telophase 2. Why? Because 4 cells have formed, nuclei are present. So that would mean that it has to be in telophase 2. Hope you got that. 6.4. Are the cells in the picture haploid or diploid? Getting too used to know a little bit of terminology. These are haploid. Because it's a gamete. Gametes are haploid. That's the end product of meiosis. Explain the importance of reduction division to sexually reproducing organisms. Right, a little bit more of a longer question here. Going to see how you can use your words to explain. So, first of all, how would you answer this? Tell me what is reduction division. So, reduction division is the phase of meiosis where the number of chromosomes is reduced by half. That's the first point. Okay, so that is what reduction division is. Why is that important? Because sexual reproduction is the combining of 2 cells. Sorry, let me just get this. So we have the combining of 2 cells' genetic material. If no reduction, too many chromosomes are present. Remember, the whole reason why is meiosis important? To prevent the double chromosome or the double chromatid number. So in this instance, it's double chromosome. So we have to have the combining of 2 cells because we are sexually reproducing. So therefore, if we didn't reduce it, we would have too many chromosomes. So therefore, the reduction division ensures the correct number of chromosomes. Okay, the 1 mark telling me what is reduction division, and the 2 mark explanation as to why that then is important for a sexually reproducing organism. Yeah, moving on. The picture below shows abnormal creation of sperm cells. So I'm telling you that it is abnormal. So make sure you try this question first by yourself because it's a slightly more complex one. So it says name the process occurring above and state the organ in which it is occurring. Yeah, well, we know that this is meiosis. Okay, so first of all, a little tip about when you're presenting your answers again. You've been given 2 things. Name the process and state the organ. So set it out for me as the examiner. What is the process? Meiosis. Then it asked for what is the organ where it is being produced. Tell me. Organ, and because this is being sperm, we know this is the testes. If you just say testes and meiosis or meiosis and testes, you haven't shown me that you have the understanding of what is the process and what is the organ. So you need to make sure that you do that. Set things out so that I can understand what you are doing. Right. Okay. Then, if a sperm with 23 plus X, so one of these ones, were to fertilize a normal ovum, what would the sex of the offspring be? So remember, when we're talking X and Y, I am referring to the sex chromosomes here. So the X sex chromosome and the Y sex chromosome. So remember, this has come from a man. That's why there's X and Y. The egg of the female, what is the potential gonosomes that the female can have? It can only be an X because a female is XX. Therefore, the only chance or the only option for this is that the offspring will be female. Because it's one X, The only other potential alternative it can combine with is an X from the female. So, can only be female. Right. What will the number of chromosomes be for the zygote formed in question 7.2? So now you have to remember that this X or Y counts as one chromosome. So in these two sperms, how many chromosomes are there going to be? It's going to be 24. 24, because it's 23 plus 1. 23 plus 1. If it was then fertilized with a normal ovum, what would a normal ovum have? It would be 23. So all you're doing then is 24 plus 23. So the answer is 47 chromosomes. I could have even asked you to show your calculation. It would then be 24 plus 23. I could have said justify your answer because a normal ovum would be 23. This one is 24. So hope you managed to get that as your answer for that in your understanding. Almost there, almost there. 7.4. An offspring is created from one of the sperm above. So I haven't told you which one. So it's created from one of these sperm. But you can probably hazard a guess as which one I'm going to. The following karyotype was found during an amniocentesis procedure done. Now, what is amniocentesis? Have we done that yet? You kind of have sort of had a mention of it. So amniocentesis is when you take a sample of the fetal cells. Pretty much they generally try and take it from the umbilical cord. So while the baby is in the womb, a needle is stuck into the womb and they extract some of the cells, and then they are able to do genetic tests on it, such as creating a karyotype. So that is what amniocentesis is. So remember that. You do need to know that. Right. What is meant by the term karyotype? Okay, so this is pretty much our definition. We did it before. So it is a visual representation of the chromosomes, or the chromosome complement of an individual. A visual representation showing the chromosome, a picture of the chromosomes that an individual has, something along those lines. Then, identify the gender of this individual and the disorder they have inherited. So I've set it out nicely for you. But I've asked you for the gender. What is the gender of this person? It is female. Do you see? Remember I told you before in the previous video, even though there's a Y here, that doesn't mean there's a Y chromosome here. There's no space. It's a space. It's empty. There is no chromosome here. But what I do see is two X chromosomes sitting here. So the gender then is female. Don't get tripped up by that although there's a Y here, that doesn't mean there's a Y chromosome here. It's a space. It's empty. It's what we use to indicate if there would be a Y chromosome. And what is the disorder? Well, there's only two that you need to know about. I haven't given it in case study format. So is it Klinefelter's? No, because it's XX, not XXY. But chromosome 21, there are 3 of them. So we know that therefore is Down syndrome. Hope you managed to remember that. Right. State one phenotypic outcome of the disorder mentioned in 7.4.2. So, what would the person with Down syndrome potentially look like? Not mental things, phenotypic. What does the person look like on the outside? So you could have said slanted eyes, facial deformity, the thing about the space between the toes is large, the first and the second toe, large crease in palm. Any of those really was potential. Go back to the video where it shows you all those different physical outcomes of that person. But it's actually just stating one of them. Okay, 2 more questions, but the more applied, really think about it questions. The risk of miscarriage is roughly 1 to 2% when having an amniocentesis conducted. The woman who is carrying the child from the above karyotype is 47 years old. Suggest one reason why it would be recommended for a woman of her age to have an amniocentesis done, knowing the risk of miscarriage exists. So, just to sort of clarify, in terms of Down syndrome, the reason that it generally happens, or one of the reasons that increases it, is age. So we know that Down syndrome chance increases with age. So women above 40 have a greater chance of having a child with Down syndrome. So although in this particular example where we came up to here, this was the sperm that was creating this, a lot of the times most of this happens with the egg itself. So again, the reason why you would want to have it as if you are for someone who's of this age is that there is therefore a high chance that she is going to have someone with Down syndrome. Therefore, it's good to have the amniocentesis. Yeah, so that is why someone of her age, and we're linking that to what it is. Okay. You could maybe go and talk about, well, it really is sort of low percentage chance that the miscarriage is happening. So therefore, it's a much better benefit as opposed to positive. That's just really going much further into what your 2-mark explanation is. Okay. Then the last question, and I'm going to finish off here. Doctors are wanting to implement a law that all pregnant women over 40 years old must have an amniocentesis conducted. Do you support this decision? Justify your answer with one well-explained point. So please remember with these types of questions, when it asks for your opinion, do you agree, do you disagree, you cannot fence sit. You have to give a definitive answer. It is either yes, or I agree, totally, or no, I disagree, totally. You cannot give both sides of the argument. You have to give one specific answer. And in this case, it asks for one well explained. So choose one theme and discuss it in depth. So again, there's no right or wrong answer for the yes or no. We do not judge you if you say, no, I don't agree with it, and be like, oh my gosh, why would this person think that? No, what we are testing is your ability to create a scientific argument. So what we're not looking for here in this type of answer is, do you support it? No, because who would ever want to do this? I am my own body and my decision. You know, these people are just wanting to hurt me. No, there's no emotion in this particular answer. You have to be scientific in your answer. So, let's say, for example, you say, yes, you agree with their decision. Because why from a scientific perspective? You know, if, say, you could say the benefits of knowing that you potentially have a child with Down syndrome, for example. So, the knowledge gained regarding disorders of the offspring can help the family prepare both mentally and financially. So, for example, if the person finds out that they have a Down syndrome child from the amniocentesis, they can then start preparing and doing research to know, how am I going to live with this child who has Down syndrome? What things should I be looking at? What things should I be preparing for? Do I have to set aside a certain amount of money? Must I start saving? If I don't do an amniocentesis, then I won't know this, procedure. You could then also argue, based from what we previously said, the chances of a genetic disorder increase with age. So it is a valid precaution to ensure the mother/family is informed. You could have argued from that perspective. Let's say, for example, you say no. So this is where we're starting to get a little bit of ethics. The doctors are wanting to make sure that if all of them must, it remains a choice. A mother should choose to have a medical procedure as it carries risk. So you can't force this on me. There's risk. It is an invasive procedure which may harm both the mother and the offspring. You could have said, although it might be something where you have the knowledge and you can mentally prepare, it doesn't make a difference. There's no difference based on the answer. Again, if someone is more sort of, wanting to make sure that they're going to have the child, doesn't really matter. Even though I found out about it, it's going to be what it is. You could potentially argue, although that's a slightly weak argument that you have from there. Those are your first main two arguments that you have there. So you see, I haven't sat and I've said, well, in some cases, yes, but in some cases, no. It's always been the one definitive answer that we have to have. Okay, so that ends the recap or the revision this revision on meiosis. Hope you guys did well with those questions. Again, if you have queries from yourself, please get me on Skype, on Teams. Let's have a meeting. Let's discuss. I really want to make sure that you understand this process of meiosis and that you understand the questions being asked of you. Otherwise, happy studying, guys. Hope you're enjoying. Thanks very much for the hard work.